This video is about identifying leading term, leading coefficient, degree, and constant term of a polynomial in a single or one variable. Let us define first the leading term, leading coefficient, the degree, and constant term for a polynomial of one variable. So for a sub n, x raised to n plus a sub n minus 1, x raised to n minus 1 plus and so on, plus a sub 2 x squared plus a sub 1 x plus a sub 0. The leading term is the term with the highest power of the variable. So for a polynomial in descending powers of each variable, the first term is the leading term. In the leading term, you can find the leading coefficient. It is the numerical coefficient, or coefficient in short, that is a sub n. You can also find the degree of the polynomial in the leading coefficient. The degree of the polynomial is the highest power of the variable. So it is denoted by n. And for the constant term, it is the last term if the polynomial is in standard form or in decreasing power of the variables. That is a sub 0. It is the term without a variable, though technically it has, or it can have, a variable with the power of 0. So that is a sub 0 x raised to 0. We ignored x raised to 0 because it doesn't affect the polynomial. And in addition to that, x raised to 0 is equal to 1. Then 1 times a sub 0 is a sub 0. Alright, so let's have an example. Okay. Number 1, 2x raised to 4 minus 5x cubed minus x squared plus 7x minus 3. The polynomial is arranged in descending powers of its variables, so it is in standard form. Let us identify the following. So if it is in the standard form, the leading term is the first term. That is 2x raised to 4. So I'm going to place this here. And then the leading coefficient is found in the leading term, and that is 2. And the degree of the polynomial is also found in the leading term, and that is 4. The constant term is the term without a variable, that is negative 3. Another example. Number 2, 28 plus 6x minus 4x squared plus 10x cubed minus 12x raised to 5. This polynomial is arranged in ascending order, the opposite of the standard form. So let us identify the leading term. So in this form, the leading term is the last term. Okay, negative 12x raised to 5. Of course, the leading coefficient is found in the leading term, and that is negative 12. And the degree is found in the leading coefficient, and that is the highest power of the variable x, and that is 5. And the constant term is the first term in this form, and that is positive 28. Alright, another example. Negative 3x raised to 4 plus x raised to 6 minus 1 plus 4x cubed plus 9x raised to 5 minus 3x squared minus 7x. Alright, so let us identify. You need not to arrange or rewrite the polynomial into standard form to be able to identify the following. We know already that the leading term is the term with the highest power of its variable, and that is positive x raised to 6. And in the leading term, leading coefficient is found, and that is 1. The degree is found in the leading term, it is 6. And of course, the constant term, the term without a variable, and that is negative 1. Another example, number 4, negative 10x squared minus x cubed minus 7x. So the term with the highest power of the variable is negative x cubed. That's the leading term. In the leading term, we can find the leading coefficient, and that is negative 1. The degree of the polynomial that is found also in the leading term, and that is cube or 3. And the constant term is the term without a variable. So there is none. Number 5, 2 times quantity of x minus 2 times the quantity of x plus 3. This form is in factored form, so we have to simplify or expand first. Alright, so how do we do that? Multiplying 2 times x. Now where did we get that? 2 times the first term of the binomial x minus 2, and then the first term of the second binomial x plus 3, and 2 times x times 3 by the power of or law of exponents. In multiplication, same base, add their exponents, and then multiply their numerical coefficients, and that is 2x squared. That will be the leading term. Okay, in the leading term, we have the leading coefficient 2, degree 2, and the constant term, we're going to multiply 2 times the second term of the binomial x minus 2 times the second term of the second binomial x plus 3. So we have 2 times negative 2 times positive 3 is equal to negative 12. That is the constant term. Another example, negative quantity of x plus 1 times quantity of 3x plus 2 times the quantity of x plus 2. So again, we're going to expand the factored form by the distributive property. So negative times, to get the leading term, multiply negative times all of the first term of the three binomials. That is negative times x times 3x times x. That is equal to negative 3x cubed. That is the leading term. And in the leading term, we have the leading coefficient, negative 3, and the degree, that is 3. And then let's go back to the factored form to get the constant term, again by distributive property. We're going to multiply negative times the second term of all the three binomials. Okay, we have negative times positive 1 times positive 2 times positive 2. Okay, to write this, and then the answer is equal to negative 4. That is the constant term. Okay, so I hope you've learned something from this. Bye!